Good day, students. So welcome to part 3 of the Algebra 2 Trigger Regents review for June 2013. In this installment, we're going to be going over questions 11 through 15. All right, let's take a look at question number 11. It says, in the right triangle below, what is the measure of angle S to the nearest minute? Okay, so let's see. We're dealing with a right triangle trig here. So the first thing that should come into your mind is the fact that we are going to be using SOHCAHTOA, because that is what determines the relationship between each pair of sides and a specific reference angle for a right triangle. If we're just dealing with sides only, we use the Pythagorean theorem, but since an angle is mentioned here, we have to make use of SOHCAHTOA. Okay? All right, so let's see. The angle under consideration is angle S. So we're going to go ahead and mark this angle. This is the reference angle here. So this is the angle that we're going to use to label our opposite, hypotenuse, and adjacent, okay? So this is a reference angle, angle S. That means that the side opposite angle S is known as the opposite, okay? So this is the opposite right here. This is the side opposite the 90-degree angle is your hypotenuse, and then the other side is your adjacent. In this problem, we don't know the adjacent and we don't need it, so it doesn't really count here, okay? So all we care about is opposites and hypotenuse. All right, so which trig ratio involves O and H in SOHCAHTOA? O and H is sine, okay? So we're going to set up the ratio sine of angle S is equal to opposite, which is 8, over the hypotenuse, which is 17. That's what SO means, okay? So we want to get S by itself. So to do that, we're going to take the inverse sine of both sides. So you take the inverse sine of sine S on the left, and then on the right side, you take the inverse sine of 8 over 17. All right, so sine and its inverse are inverse operations, so you're going to have S equals the inverse sine of 8 over 17. Now what we're going to do is we're going to use a calculator to determine the angular value that is equivalent to inverse sine of 8 over 17. All right, so this is what we're going to be calculating, inverse sine of 8 over 17. Since our answers are in degree, minutes, and minutes, when you turn on a calculator, you want to make sure that your angular measure is in degrees as opposed to radians. So how do you check that? You press mode and make sure that degree is highlighted, okay? So as you can see here, I have degree highlighted, so this is what you want. All right, so now what I'm going to do is enter this expression, inverse sine, second function sine of 8 over 17. And your answer is 28.0724 degrees, okay? Now, 28.0724, let's write that down. 0.0724. Okay, now this is the answer. This is degree, and this is in decimal. Okay, so we want it to the nearest minute. So you have to be really careful. This is in decimal form, and you might be tempted to round this up to the first decimal place, and you have 28.1 and write it as 28 degrees in 1 minute. That's wrong. Okay, we have to convert this decimal portion of the degrees into minutes. All right, so the way you do it is look at degrees as hours. Okay, if degrees is hours, then the decimal component is going to be the minutes. So how many minutes are there in an hour? You have 60 minutes in an hour. So to convert 0.0724 hours to minutes, you simply multiply by 60. Okay, so remember, if you want to change 1 hour to minutes, what do? You multiply it by 60, right? So 1 hour times 60 changes you from hours to minutes. So since degrees is just like hours, if you want to change it to minutes, you just multiply by 60, okay? So to convert this decimal component of the degree measure to minutes, you just simply multiply 0.0724, you multiply that by 60, okay? And that will give us the minutes of this decimal expression. So let's go ahead and compute what that is. So we have, let's see what we have, 0.0724, you can put 8 if you want, times 60. So it's 4.34. So to the nearest minute is going to be 4 minutes. All right. So let's put that down. So it's approximately 4 minutes. Approximately 4 minutes. So that tells us that this value, 28.0724 degrees, is the same thing as 28 degrees and 4 minutes approximately. All right, so this is what the value of S is. So S is approximately 28 degrees and 4 minutes. So don't forget, degrees is like hours, all right? And then the decimal component, you can change into minutes. So that's how you do it. So our answer for number 11 is option 2. All right, let's shift our attention to number 12. It says, which ordered pair is in the solution set of the system of equations shown below? So we might have more than one solution. All that we care about is which of these is part of that solution set. Okay, so that's the question here. So there are two ways you can do this. The first way you can do this is by substitution. The second way you can do this is by plug and chug. You plug in all these answers to see which one satisfies both equations. I'm going to use the substitution approach first. So by substitution, let's call this equation 2. Call this equation 1. You notice that I can easily isolate x here. So from 2, what do we have? From 2, we have 3y minus x equals 0. So I can add x to both sides. So add x, and then that yields 3y equals x. So what we're going to do is we're going to substitute 3y for x in the other equation, in 1. Okay, so if we do that, this second equation is going to become y squared minus, instead of x squared, I'm going to replace it with 3y squared plus 32 equals 0. Okay, so let's go ahead and solve that for y. Okay, so let's do it. So we're going to have y squared minus, if you square 3y squared, do not forget to square the 3 and the y. Okay, so that makes this 9y squared plus 32 equals 0. Okay, so we can subtract 32 from both sides. And then since these two are like terms, we can combine them, okay? So imagine that there's a 1 in front of this y squared, negative 1. I'm positive 1 minus 9 is going to give you 8y squared equals, let's see, yeah, negative 8y squared equals negative 32. Okay, so divide both sides by negative 8. Remember the goal is to isolate y. So divide both sides by negative 8. So you're going to have y squared equals 4. And you take the square root of both sides. Let's use a different color for that. Y squared equals 4. Take the square root of the left side and the right side. And then you have y equals plus or minus 2. So you notice that there are two solutions for the y. So which of these has plus or minus 2 as a solution, as a coordinate for the y? We can see that option 4 does. So there goes your final answer. All right. If you wanted to do plug and chug, all you do is you take your x, plug it in, see if x and y, and plug them in, see if it works. So that's basically how you do the plug and check. Okay. All right. So there you have it. Now let me show you how to do the plug and check method, just in case you don't. This is too abstract for you. So method 2. I'm gonna just be lazy here. I'll just do the correct answer to show you how to do it. Okay. So for method 2, I'm going to plug in x equals negative 6 and y equals negative 2 in both equations. And if it satisfies both equations, that means it's the correct answer. So for the first equation, we have y squared minus x squared plus 32 equals 0. So let's plug in these values. So the question is negative 2 squared minus negative 6 squared plus 32 equals 0. Negative 2 squared is 4, minus negative 6 squared is 36, plus 32 is equal 0. Subtract these two is negative 32 plus 32 equals 0. Isn't it? Absolutely. So that checks out. And then we have to check the second equation. The second equation says that 3y minus x equals 0. So 3y minus x equals 0. So you're going to plug in these coordinates. 3 times negative 2 minus negative 6 is equal to 0. 3 times negative 2 is negative 6. Minus times minus is a plus, but 6 is equal to 0. Negative 6 minus 6 is 0. 0 equals 0. That checks out. All right? So if you didn't know what the answer is, you just repeat this process for all the four options. Only one will satisfy both equations. Make sure that your plug and chug satisfies both, not just one equation. All right. All right, let's shift our attention to question 13. It has to do with an application of exponential functions, exponential growths to be specific. So Susan invests 500 in an account that's compounded continuously at an annual rate of 5%, according to the formula A equals PE to RT. Where A is the amount accrued, P is the principal, R is the rate of interest, T is the time in years. Approximately how many years will it take for Susie's money to double? All right, so you just need to know what all these variables mean. At the end of the day, you should have one equation with one unknown, okay? So remember, E is a number, okay? So let's list what our variables are, what they mean, and see which one we're looking for, okay? So P is called the principal. Principal is just a fancy word for starting amount, okay? So starting amount. In this case, it's what is it? It's 500. Okay, and then A is the accrued amount. Is a fancy word for final amount. How much did he have after the period that was under consideration? So what's the final amount? It talks about doubling here. So basically, you double P, right? If you start with 500 and you're looking for when it doubles, you're looking for when it's going to be twice what you had initially, which is going to be 1,000. All right, and then R is the interest rate. Okay, in this case, the annual interest rate is what is the annual interest rate? Is 5%. We have to change this to fraction or decimal. 5% is 5 over 100. If you convert this to decimal for easy computation, we have to move the decimal point forward twice. So it's going to be 0.05. Okay, and then T is how long it takes for amount to double. Guess what? That's what we're looking for, because it says how many years. But that's what we're looking for, okay? So you notice that we have 4 variables. We know 3. We need the last one, okay? So let's plug all of this into the formula for calculating the amount. So let's rewrite the formula again. A is equal to PE to the RT. This is for continuous growth. So amount is 1,000. We have 1,000 equals 500 e to the r is 0.05t. Okay, so start out by dividing both sides by 500. The goal is to get t isolated. Okay, divide both sides by 500. 1,000 over 500 is 2 equals e to the 0.05t. Okay, I want to power down this exponent right here. The only function that can enable us to do this is a natural logarithm. So we take the natural logarithm of both sides of the equation. So natural logarithm of 2 equals natural logarithm of e to the 0.05t. So this cancels out with that since your inverse operation. So we have the natural logarithm of 2 equals 0.05t. To finish this up, we just divide both sides by 0.05. So we can figure out how long it's going to take the amount to double at that interest rate. Okay, so divide both sides by 0.05t, and then our final result, t, is going to be, let's bring out our calculators. We're going to compute here. We're going to compute the natural logarithm of 2 divided by 0.05. All right, so your final answer is going to be 13.9 to the nearest decimal place. Okay, to the first decimal place. So it's going to be 13.9 years. So you can clearly see that our answer is option number 3. Okay, number 14. It says if n is a negative integer, then which statements is always true? There are different ways you can do this. You can graph these functions, or you can plug and chug. Um, what I'm going to do, I'm going to basically plug and chug, but you can always use a graphical exploration. Just graph it and look at the left side of your graph to determine it. Okay, so what I'm going to do is we're talking about negative integers, so I'm going to test um, n equals -1. Okay, that's my test number. And I hope that only one passes the test. If more than one passes the test, then I'm going to try more, maybe try -3 or resort to graphing, okay? So let's try this first negative number, first negative integer, and keep our fingers and hope that it works out, okay? So option one, remember which is always true. So if we have a false statement, that's not the answer. Whichever one is true, that's the answer, okay? All right, so option one, 6n to the -2 uh, can be written as 6 over n squared. And is that less than 4 to the n minus 1 can be written as 4 over n. Okay, so that's option 1. So if I plug in the values, I'm going to have, is 6 over 1 square, is it less than, I'm sorry, -1 square, is it less than 4 over -1? So 6 over -1 square is simply 6. Is 6 less than -4? That's the question. Is 6 less than -4? Absolutely not. 6 is greater. So that's false. That fails. So that's looking good. We have one that has been eliminated from our answer choices. So let's move on to the next one. Option 2. Is n over 4 greater than, this is option 2, is n over 4 greater than -6 over n to the -1 is just n. It's just over n. Any variable with a negative exponent gets reciprocated, okay? So let's put in our test number, -1. So it's -1 over 4 greater than -6 over -1. So it's -1/4 greater than a positive number 6. Absolutely not, because this number is negative and this is positive. So we see that this is wrong. All right, let's shift our attention to number 3. Number 3, we can rewrite this as a 6 over n less than 4 over n. Is it always the case? So let's try -1. So we have 6 over -1 less than 4 over -1. Is -6 less than -1? Absolutely. So this checks. So this is looking really good. Now we have to try number 4 also, because -1 might work for these two. Then we have to try another number until one of them fails. Okay. If one doesn't fail, then we have to we have a problem. Okay. So we have to keep on trying until one of them fails, or we have to use another method like graphing. So let's try number 4. Let's hope that it fails, and then we know that number 3 is the answer. Okay. So we have 4 over n. Because n to the -1, you reciprocate that. Is it greater than 1 over 6n? Notice I reciprocated both numbers, both items in the parentheses, because this -1 affects both of them, okay? All right, so let's plug in the test number. -1 is 4 over -1 greater than 1 over 6 times -1. Is -4 greater than -1/6? All right, the answer is no, absolutely not, because this number, if you look at your number line, -4 is farther to the left than -1/6. -1/6 is closer to the right, so that means -4 is much smaller. In the negative world, is much smaller. If you owe a sixth of a dollar, you're richer than someone who owes $4. Okay, this is not even up to 1. So we can clearly see that this is false. So our final answer is option 3, because 4 failed. Okay, so there you have it. All right, let's shift our attention to question 15. All right, let's take a look at number 15. It says the expression 4 plus the discrete sum from 2 to 5 of 3 times k minus x is equal to. So for this one, we are basically going to generate the terms for this discrete sum right here, and then add it to 4 and see which one we get. Okay, so we're going to focus first of all on the summation part. From k equals 2 to 5, of 3 times k minus x. So what we'll do is we're going to use k equals 2, 3, 4, 5 to generate the four terms that this expression represents, the sum, and then we're going to add 4 to our final answer, and that will give us a result, okay? All right, so let's compute what the terms are, or let's generate what the terms are. First one is k equals 2. Remember, the bottom number is where you start. This is your start. And then the top number is where you stop when you're carrying out your iteration, okay? So that's your start and that's your stop. All right, so for k equals 2, we have 3 times 2 minus x. Remember, the 2 goes in the k position, not the x. You have to be careful here, okay? So if you simplify this by distributing the 3 to the 2 and a negative x, you have 6 minus 3x. And there goes the first term generated by this discrete sum. For k equals 3, we're going to compute 3 times 3 minus x, which gives us 9 minus 3x. And then for k equals 4, we're going to do 4 times 3 minus x, which yields, actually I got it switched around, let me fix this. We're going to do, it's going into the k spot. So it's going to be 3 times 4 minus x. Okay, distribute the 3, you're going to have 12 minus 3x. And then for k equals 5, you have 3 times, let me color code it. Let me change the color so you can see what's happening here. 5 minus x. Okay, so that's the number that's changing. So you have 15 minus 3x. Okay? All right, so I just changed these colors to make it obvious where the substitution is happening in. Okay, so let's add that up. So we just add the integer component of this expression. 6 plus 9 is 15. 15 plus 15 is 30. Plus 12, that's 42. And then there are 4 3's here. 3 times 4, that's 12. 12x, okay? All right, and then we add that 4 that we had there before. So we plus 4. So this is an integer, we'll combine it with that. So we're going to have 46 minus 12x as the final answer. Answer is option number 4. All right, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to future installments of this review series. Please post a comment to let me know what you think about this clip or any questions you have on any questions so I can answer it for you. More of the test review items can be found on matgorserve.com/testprep, or you can just scan this QR code for direct access to the website. Thanks again for watching. Have a wonderful day.